You'll see how you did on each question, each individual question. I put a grade out of how many points there were. So go to Canvas, go to our assignment, go to your thing that's uploaded, and you should be able to see it. And I'm happy to sit down and kind of talk through that with you. How you did and where you went wrong and where you went well, you know, what went good for you, all that stuff. So so if you want to take a look, you can do that. Okay. You can check out those grades. Check E for a second. And in general, things were pretty good. Things were pretty good. I haven't done the in-class stuff at all. I haven't looked at that one bit, but I looked at it when you guys were handing it in, so that wasn't too bad. On Canvas, go this way. I want to start kind of looking forward a little bit. And so whether you're at home right now listening, or you are sitting right here in front of me, at our most recent announcement, okay, today's announcement, there's a little link that says click here when I tell you to in class. So we're going to do that in just 1 second. But I wanted to first ask if anybody did not have a first period class today. Is anybody off first? Well, I have my first period on. Okay. So did you hear about what happened this weekend? Okay. Does anybody have anything that they want to talk about? Is everybody kind of doing okay? There's a lot of resources that are here today down in 119, so that if you have any questions, if you're struggling with the news of Jillian's passing, and whatever you need, just know that there are a lot of people here for you to support you in whatever you need. I know it came as a shock to all of us, and she's going to be very missed for sure. So if you need anything, please let me know. Please let a counselor know. Please let anybody know if you're having any trouble, okay? Because we're here for you. So, okay. I know. So on this announcement, let's click here now. Click on that for me. It's a survey that I want you to take. So everybody's going to have to do it. So I don't care if you do it on your phone or you do it on your desktop or anything. I don't care how you do it, but click on this link. Okay.
This is how you use it.
I just want to see how these last 4 weeks should go. There's a lot of stuff that I want to talk about, and I want to make sure that I'm doing what's best for kind of everybody. Jaden, if you could mute yourself, bud. Okay, on today's announcement. Okay, so go to Canvas, go to our class, go to today's announcement, and that link down there at the bottom, click here when I tell you to in class, just open that up. And there's a few things that we have not done yet on the See You Succeed final that we're all taking before the end of the year. Whether you're See You Succeed or not, we all take the same final because it's all the same class anyway. And so what I wanted to do with this survey, starting first with the topics that are going to be on the final. On a scale from 1, I'm not comfortable at all with this. I really need a lot of help. I don't even know what you're talking about, kind of thing. All the way to a 5. I'm ready. I know exactly what this is. And give me the question right now. I could ace it. I want to see how comfortable you feel with the following topics that are on the See You Succeed final. Okay. The first one, solving an equation that has a square root. And what I mean is like the square root of 2x minus 1 equals 3. solve it. How comfortable are you with this question? On a scale from 1, I have no idea how to even start, up to a 5, I could definitely do it. You need to write it down, because I'm going to use these results to figure out how I want these last 4 weeks to go. Okay, so this survey is very important in deciding how I move forward. Okay, because I want to do what's best for you to prepare you for the final, to get us to trig, and then of course to calculus as early as we can. But I want you to be successful. Okay, next slide. Over to here, so you guys can see that a little bit better. Okay, solve an equation like that. Okay, and then you can go through it as quickly or as slowly as you want to. I'm going to talk through each one. Finding the equation of a line perpendicular or parallel to a given line and through a given point. So I would say, like, here's a line, y equals 3x plus 4. Find the equation of a line perpendicular to this one and through the points like 2, -1. So your answer is going to be y equals something x plus something, right? Solve for it. Exactly. So if you can figure out what the slope would be and how to proceed with that, 1, I'm super lost. 5, give it to me right now. I'm ready. Okay. Write the equation of a circle. Given the center of that circle and the radius. 1, I have no idea how to do that. 5, I'm super familiar with that. Give me the question right now. We have not done that. That is not something we've talked about yet. Okay, so that would be something that maybe you remember from years past. Okay. Next one, find the domain of a rational function. That should be very recent stuff. But again, you still might not feel like it's a 5. That's okay. Just tell me how you feel. 1, I'm not comfortable at all. 5, super comfortable.
One problem, I would like to remember.
Find the domain of that function. Okay, find the vertex of a quadratic. So given some quadratic function, find the location of the vertex. And this is all multiple choice, by the way. The whole final is multiple choice. Okay, with partial credit available if you show work. Okay, but you can get the whole question right if you get the right answer. Okay. Okay, so find the vertex of a quadratic. So I would give you like f of x equals 2x squared plus 6x minus 1 and ask you to find the vertex. Okay, determine the degree of a polynomial in both standard form and factored form. So I could ask you, hey, like, what's the degree of this? And I could also ask, hey, what's the degree of that? Okay, so that's that one. Determine the degree of a polynomial in both standard form, something like this, or factored form, something like this. Knowing that you're looking for 2 different things, right? 2 different things. 1, not comfortable at all. 5, super comfortable. And like, so I have the final, I know what's on it. And these are the types of questions that you should expect to see, okay? Find the asymptotes of a rational function, so finding the vertical one, and being able to find the horizontal one or an oblique one. That's, again, super recent stuff. Solving an absolute value equation, something we have not done in here. The absolute value of 2x plus 5 is equal to 3. Solve that algebraically. Find the values of x that make that true. Maybe this rings a bell. 2x plus 5, drop the absolute value and put a plus or minus in front of the 3. If that is brand new to you, then you're more in the 1 or 2 kind of range versus a 4 or 5. Find the inverse of a linear function. Find the inverse. Inverses. Okay, that was definitely last year. Here is a function, f of x equals 2x plus 3. Find the inverse algebraically. Okay, find a function that does the exact opposite of f of x. All right, take x and y, switch x and y, solve for y. Okay. This one might be new. I'll probably talk about this whenever we decide to review and kind of fill in these gaps. Given two functions, evaluate the composition of those two functions at a given x value. Okay, so it looks like this. F of x is something. I give you a function. G of x is something else. Okay, you're given those two, and I ask you to do this. The composition between two functions at an x value. Also written like this. So not of x, but of 3. Find the answer to that. You plug in 3 into one of them, and then you plug in the answer to that into the other one. It's like a double evaluation kind of thing. It's called composition. Then we start getting into logs and exponentials, which is what this upcoming chapter is. And I'm going to focus us just on the stuff that we need. Finding the domain of a logarithmic function. Just the domain, not solving anything, but here's a function. What's the domain of it? So I say, okay, f of x equals log base 2 of x plus 1. What's the domain? What x values work? Okay. Solving an exponential equation. 3 to the x plus 1 is equal to 27. Solve it however you want. You can reduce spaces. You can use logs. You could just figure out what number is going to work. Okay, solve a logarithmic equation, kind of doing the same but going the other way. Log base 2 of x plus 7 equals 3, something like that. Solve that. Probably stuff you saw last year, right? You saw logs and exponentials last year. And then one more. Given a zero of a polynomial, a complex zero of a polynomial, what's the other one? All right, so say x equals 3 plus 2i is a zero of a polynomial. What's the other one guaranteed? Positive 3. So only switch the sign in between. Complex conjugate, all right? Okay. All right, and so hopefully you answered each of those somewhere between 1 and 5. And then one final question. Okay, and this one is really the most important one. Based on your response to this form so far, what do you think is the best thing for me to do as your teacher to get you ready for what's coming down the road? Okay, and a lot of these have just little tweaks to them, so fill in the gaps of the topics we haven't covered yet. And let's do that this week. All of the things that maybe you answered 1 or 2 or maybe even 3, let's talk about those this week. I'll send out a review at the end. Okay. We'll take Thanksgiving week off and we'll review live just on Monday. Okay. You'll have the whole week to kind of work on. And so when I say take it off, I mean you just do your thing during Thanksgiving, looking at that review as much as you need to now that we've gone over everything. We'll review live on Monday. And we're remote. You know that, right? After Thanksgiving. Okay. So we'll review live on Monday. You'll take the college algebra final on Tuesday, multiple choice. Okay. We'll start trig on Wednesday. And during finals week, you won't have a final, but I will have an assignment for you to kind of keep trig going. Okay. That'll get us there fastest. Okay. We will start calculus as soon as possible, and that's kind of the goal. To start as early as we can. Okay, so that was option number 1. Option number 2, pretty similar. Fill in the gaps and topics we haven't covered this week. I'll send a review at the end of this week, but we'll review live for 2 days. I'll do a Monday class and a Tuesday class, and we'll take the final on Wednesday. So that just puts us back 1 day. That's just 1 day difference. So 1 more day of review, but we lose 1 more day of trig. Okay. Fill in the gap, option number 3. Fill in the gap topics we haven't covered yet this week. Take all of Thanksgiving week off. I give you nothing, okay? I send out the review the Monday, and then we'll review all week. That pushes us back about like half a week, okay? We'll review all of the week that we get back, okay? We'll take the CU College Algebra final the following Monday, which would be the last week before final. So it's like we're taking the final a week early, okay? We start trig, so we'll do trig for a week, and then I'll send you just a regular assignment during finals week. Okay, so those are kind of your 3 options to do things early, to take the final early so you have less to prepare for during finals. Okay, the 2 options that have the final during finals. Because I have it, so I can give it to us whenever. Okay, fill in the gaps of topics we haven't covered this week, then just do trig. Go right to trig. Okay, we'll spend a week and a half doing trig, and then I'll stop to review in class for a day or 2 to prepare you for the final during finals. Or we start trig right now. We do 2 weeks of trig. I stop to review, then we take the final. So it's like we're going to start new stuff that you don't need for the final. Then we go back and we study for the final and then take it. That's why it's the last option. I think that that's kind of a tough choice, is to go through and say, you know what, I'm going to start new stuff and then fill your brain with stuff you don't need, then test you on the old stuff, and then come back and we go back to the trig. That's why that option's last. I think that would be the hardest one. But I want you to respond to that and submit. Okay, circles. Absolute value, inverses, composition, logs, exponentials. Okay. And most of us seem to like that third choice, which I can't even remember what it was now because it's so long. That probably just has more review, right? I think that was the one where we don't get the review at all. We do a week of review after Thanksgiving. We take the final on that Monday. The other majority said kind of the same thing, but they want to get stuff done as early as possible. So almost everybody liked, besides what just looks like one person. Let's fill in some gaps. Let's see how we do. I will send out the review. I'll probably send it out early so you can start reviewing once I have it. And then I'll send you the CU review because they make one up too, which is really nice. And then we'll go from there. Okay, so let's do that. Let's fill in the gaps a little bit right now with some of the things that seem to have popped up here. And for me, it looks like logs and exponentials because there's multiple questions on that rather than just like the one absolute value question or the one composition. Seems like logs and exponentials, which is the next chapter anyway, would be a good place to start. Okay, cool. Take out some of the right with something to write on. Chapter 3 in a very small way. Here in these last handful of minutes, we'll start right now. And this should be mostly a recap of last year with all their logs and exponential stuff, but it has been a while. We haven't done anything like that in here. So let's do that. You guys can come with me. Thank you all for being here. This up over there. How's he doing over here? Loving it? Good. He's a boy. Okay. Let's do it. All right. So chapter 3. Oh, you guys are waiting. Even that. Okay. Chapter 3. Exponential and logarithmic functions. Exponentials and logs. Exponentials and logs. And I'm going to try to kind of base them mostly around, because there's lots that I could show you. There's a ton of stuff I could teach you. The kind of things that are going to be on this final. Okay. Solving exponentials. So domain of logs. Where does it kind of start? Domain of logs. Solving each one. And that's about it. Okay, so we'll focus on those ideas so I can start filling in other gaps as well starting tomorrow. So quick recap on what an exponential function looks like. Exponential, yeah, function, sure. F of x, a times b to the x is about as simple as it gets. Okay. Now, I could do some shifting of the graph left and right. So by adding or subtracting a number up top here, I'm going to put x minus c up at the top there because that's a horizontal shift. And they're always backwards. They're always going to go in the opposite direction that we would expect. So I'm going to put a minus here as a reminder that it goes in the opposite direction. And then a plus d at the end there because that's a vertical shift going the other way. Okay, moving things up and down, but those are more intuitive kind of movements. If it's plus 3 at the end, it's going to go up 3. Okay, those are exponential. And a lot of times, like c is 0 and d is 0, and we just a is 1, right? You might just have like 2 to the x, or 5 to the x, or 1/2 to the x, or anything like that. Okay. But if b is bigger than 1, it's exponential growth, right? We're going to have a graph that looks like that. Okay. If b is between 0 and 1, we have decay. And it's going to go down like that. Okay. So if you've got a base, that's why we call it b, which is actually a really nice way to connect those two. If our base is larger than 1, things are going to go up as we move from left to right. If our base is some fraction or some decimal, some number, so in here, right, just in here, just the thing that's being raised to that power of x, if that number is between 0 and 1, 1/2, 0.2, 1/3, pi over 4, or whatever, things are going to go down from left to right. Okay, if b is equal to 1, it's just a flat line, right? It's 1 to the x as I'm going anywhere. If it's 0, it's 0. If it's negative, it doesn't work. You cannot, because we're taking negative numbers and raising them to different powers, we cannot really connect those at all. Okay. And a couple things are guaranteed to be true no matter what. Okay. The domain is all real numbers. Okay. Doesn't matter to me if it's growth or if it's decay. I can plug in any number I want. Look, arrows on both sides, right? Arrows on both sides. I don't even need to write it more than once because it doesn't matter. It really doesn't. I'm just going to write it once. Growth and decay, same thing. Okay. But the range is not. Okay. These functions, no matter what, have a horizontal asymptote. Okay. There's a line here that this graph is going to approach either on the left side or on the right. Okay. There's no vertical one, although it does look like it's going to shoot up really fast. There it does go up really fast, but it's just going to grow and head out forever, okay? But there's going to be a horizontal asymptote right here, okay? And that horizontal asymptote will always be at y equals this. Oh. Y equals d. Okay, and so your range is going to go from d to infinity. Not including d, because we're never actually going to get there. Remember, horizontal asymptote in this case is really an asymptote. It's a line that we're not going to cross. So we'll get really, really close to d, but then we'll just shoot up forever from there. Okay. And the only thing that could screw this up is if a was negative. It would flip the whole thing upside down, and then these would switch, and it would become negative. It'll go from negative infinity all the way up to d, or from d to infinity. And I think we're good with just d to infinity. Okay. There's all of our exponential functions. Ta-da! Amazing. Okay. Beautiful. Done. Okay. Now we go to log. This hopefully is just a super quick, ultra fast recap that just takes today and a little bit of tomorrow to actually start working through some of the things that do come up. So I saw a couple things on the review that I just want to make sure that I mention. Okay. Let's talk log. Log functions. Okay. These are the inverses of exponentials. And I know we didn't talk about inverses in here, but I know you have talked a lot about inverses in the past couple years. Okay. But basically the key for me is really just being able to work nicely between the two, okay? So if I have a log function, so I'm going to call it g of x, because that's f of x, okay? A lot of the same things can happen, right? We can have a base, we can have a horizontal shift, we can have a vertical shift, and we can have that stretch that just makes things either grow a little bit faster or a little bit slower or flip things upside down, okay? And so there could be an a out front here. But if I write a, you might think of it the same way as that one. So it really doesn't matter. I will, though. I'm going to call it a. Okay. But now we have logarithm. Log base b of x minus c. All the same things can happen, right? I could do a horizontal shift with c. I could do a vertical shift with d. But this base, okay, if you're looking at inverses, is the same base as this one. Okay, and in general, our log graphs are going to look like this. Okay, no matter what, b has to be positive. I cannot have a base that bounces back and forth. Same thing here, right? B had to be positive to make this whole thing work. Okay, these have two asymptotes. Potentially, it depends. Okay, but it will definitely have a vertical asymptote. Okay, and that will be at x equals c. So it's a little light. There is a vertical asymptote at x equals whatever that number is. This one right here. So it depends on the actual function itself. It is possible that they just go up forever. So there really doesn't have to be a horizontal one. There's definitely guaranteed to be a vertical one. And I'm not going to go any further into that. We really don't need to be able to do that. So I'm good right there with those two bases. Okay. And so an easy thing to kind of do is to say, all right, let's look at a function. Let's call it a of x log base 2 of x. And one of the questions was find the domain. One of the ones that we have to work through on this final is what's the domain of that. Okay. And so if I've got a vertical asymptote at something like x equals c, My domain of these functions is going to be from C to infinity. But in general, unless we do something crazy, that range is going to be infinite. We're going to go on forever and ever. Okay. So if we can figure out what C is here, then I should be able to just write the domain. Guaranteed. All I need is this number. Whatever this number is right here is going to go right there, because it's a horizontal shift. So what am I adding or subtracting inside here if I didn't write anything? Nothing. Yeah, 0. From 0 to infinity. And the graphs will give that to you as well. If you have a graphing calculator, when you take this final, and I highly suggest you do, all you have to do is just graph it too, and it'll kind of guarantee that you're seeing that. Let's see, I probably need a little function here. Probably in the miscellaneous, yeah, log base. Okay. Go back there. Why are you doing that? Log base, where are you, base 2 of x. Away it goes. Okay. And that graph, no matter how far back I get, just takes off, uses that x equals 0 as its asymptote, and it looks like it's flattening out, right? It looks like there's going to be a horizontal asymptote. It is not. It's just going to slowly and forever and slow, like super slow, but it will eventually cross that line. And I mean, I cannot make it big enough for you to see that it does go on forever, but it absolutely does. Okay. Cool. What if we did, I don't know, like e of x 3 log base 7 of x plus 4 minus 1. If the only thing I am going to ask you about this function is what's the domain, we really only have to look at a certain spot. I just need that number. If this is x plus 4, but this is x minus, see? What's that number? Good, the opposite. Okay, horizontal transformations are backwards, right? And if you look at the graph of it, you can see that that vertical asymptote kind of slid left 4 spots, right? There it is, x equals -4. There's my vertical asymptote, and it looks like it's gonna flatten out. It doesn't, it just keeps going. Logarithmic growth is actually a pretty good example of what happens in life. Cool. 2 more. I'm just kind of curious to see what you've seen before. C of x, I'm just gonna keep it simple. Log of x minus 3. If I don't write a base, what is that? 10. Base 10, okay. Log of something is log base 10 of something, okay. That's called the common logarithm. The common log. Okay? It's one of the most popular ones that we use. Why base 10? Because we have 10 fingers, we have 10 toes. We use the decimal system that is in base 10, right? If we used a metric system, it'd be perfect, right? Because metric is base 10. Cool. But the question that I'm going to ask, that they're going to ask, is what's the domain? Yeah. Soft bracket on both, right? Because we'll never actually get to 3 because we'll have a vertical asymptote there. And infinity, of course, we can't actually get to. Okay. One more. I'll go back this way since I got the books. This one, I wonder if you've ever seen before, and we'll probably build from here. One more function that is a logarithm, but you're not going to see the word log in it. D of x, right? Yeah. L n, not one n. Ln. Have you ever seen ln before? You have, because you had me last. Never seen it? Okay. It's a log of something. I'm going to fill this something in a second. Okay. It's a unique base. It's a base that you've maybe never seen before. Okay. All right, check this out. Imagine separately this setup. 1 plus 1 over x to the power of x. Exponential, right? But as this number gets bigger, 1 over this number gets smaller, right? 1 over, 1 to the 1. Here, let's do that. Let's just play with the calculator. Hopefully, you guys can kind of see. Okay. 1 plus 1 over x to the x power. Okay. So imagine I dropped in a 1 down here, which means I drop in a 1 right there. 1 plus 1 to the first. So 2 to the first 2. Right? Okay. Well, what if I change that 1 to a 2? Okay, so 1 plus 1/2 squared. So 1 1/2 squared, 2 1/4. Okay. Now, and this is exponential, right? Because this base is bigger than 1, right? 1 plus something is going to be bigger than 1 no matter what this is, to a power, okay, to the power of x, okay? All right, what if I change that number to like a 10? 1 plus 1/10 to the 10th. Okay, definitely, right? Because it's 1.1 times itself 10 times. Okay, so, but we're getting bigger, right? Growth. Okay, what if I keep going? Let's make it 100. Now, look at the jump, right? From 2 to 2 1/4 to 2.6 to 2.7. So I went from 10 to 100, but this only went up 0.1, basically, right? Okay. What if I made it 1,000? From 2.704 to 2.717. Pretty small jump, right? But I made a huge leap along the x-axis. Okay. What if I made it, I'll just stick with this one, 10,000. 2.718. What if I made it 100,000? 2.7182. A million. 2.71828. How many zeros? Let's add 2 zeros. 2.71828. 179. Let's add 1, 2, 3, 4 more zeros. 1, 2, 3, 4 more zeros. Basically the same number over and over again, right? And so what's happening is that even though this thing is exponential, and we know it's going to kind of take off, right? It seems like this graph is going to increase forever. It's not. This graph begins to level out. We've got a function that looks a little bit different than we've seen before. And it's because of that exercise. because we kind of balance out this x down here and this x up here with a 1 over x, which is going to tend towards 0, right? What's happening as x gets really big? What happens to this function as we get further and further away? We actually do approach a horizontal asymptote. And that horizontal asymptote, of course, is happening at some number, right? But what is that number? That 2.718 blah, 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 blah. That number is called Euler, not Euler. Euler's number. Okay, Leonhard Euler is a German mathematician that basically it was either Einstein or Euler. Like if you want to figure out what happened in math, 95% of it, Einstein or Euler, or maybe Newton. Here we talk about calculus. Okay, his number is the number E. E, wait, no, that's a letter. No, it's a number. It's that one. 2.718281828. This goes on forever. There's a nice pattern at the beginning, but it breaks down for sure. E is approximately 2.718281828 45 90 45, and then the pattern breaks down. But that first part is not all that bad to remember. 2.7 1828 1828 45 90 45. And you don't have to know all of those digits, but E is a number and it's in your calculator. Okay, if you look at your graph and calculator, it is above the division sign, second division. Okay. It is the natural growth factor. Okay. This series, okay, when we actually keep going, gets us towards E. Okay. And E is the best thing that has basically ever happened to calculus. Okay. And that's why I want to make sure I talk about it. Okay. So when we talk about ln, okay, that is the natural logarithm. Okay, log base 10 is great. Log base 2 is great. None of them work as well as log base E. Okay. Now we don't write log base E. We write ln. And you're saying, well, wait, ln. This looks like NL to me. Logaritma naturale is what this is. The natural logarithm. People that spoke English are not the ones that contribute the most to math. Okay. Okay. So when we say ln, I mean log base E. And it is on your calculator. It is right below the log book. If you look at your calculator, log's right there, ln's right there. Okay, and it is equally as important, if not more so, like log, the button that's right there is the natural log, right? That's log base 10. ln is log base E. Okay. Now that does not make a difference for us in terms of figuring out domain, right? This is just going to be from 1 to infinity, right? No problem. Whatever this number is right here. But if we don't have a background in ln or just understanding what E is, we're going to be in trouble when it comes to calculus. Okay, and that's what I want to preview for you first, is looking at the natural exponential function. Okay, and this is jumping the gun a little bit to get us towards calculus, but then once we get there, you've seen it before, and my amazement at how crazy this that I'm about to show you will hopefully sink in a little bit better this time. Questions about that? Just a number. Okay, 1 plus x, 1 plus 1 over x to the x will take you towards this magical number. Okay, it's my favorite number. This summer, I took a history of mathematics class as part of my grad school courses that I have to take to teach for CU Succeed. My final project was on the number E. Okay, so check this out. If we drew the graph of e to the x, okay, the natural exponential, Okay, this is what's so crazy about this. Okay, and we just kind of stopped at some places along the way. 1, 2, 3, whatever. Okay, so there's x, there's y, goes on forever. E to the x. Okay, stop at 0. What's that y value right there? Like if you dropped in, sorry gosh, I don't know how much you guys can see. If you dropped in 0 right there, what's anything to the 0 power? 1. Good. Okay, so the value is 1. But isn't that's e to the 0, right? E to the 0. Okay. Stop at 1. E to the first. Well, e is some irrational, long, crazy number. Okay, so just deal with it in terms of e. Don't let the letter throw you off. What's e to the first? What's anything to the first power? Itself, right? So this is just e. That spot would be e. 2.7182818. Okay. Okay, stop at 2. That spot right there. What is that? If I drop in 2 right there for e to the x, what's the best way to write down e squared if it's irrational? E squared, cool. And it just keeps going, right? Whatever x value you stop at, the value of the function at that spot, so the value of the function is e to whatever that number is, right? And of course it is. That's the function I just gave, right? That's not a very amazing part, okay? Here's where things start to get interesting. Here's where the calculus starts to come in. Imagine stopping at one of those points and drawing the line tangent to it. Okay, whether it's there, or there, or there. Like stop at one of those points and draw the line that just hits it in that one spot. The slope of that tangent line when x is 0 is 1. The slope of the tangent line when x is 1, so when you're up at e, the slope of that line is also e. The slope of the tangent line at 2 is e squared. The slope of the tangent line at 3 is e to the 5th. The slope of the tangent line at any spot along this function is exactly the same as the value of that function. So if you know the value at that spot, you know the slope of the tangent line. And this is what we deal with in calculus. Slopes of tangent lines on curves that are changing, right? Because as the curve moves, the tangent line is moving with it. Okay, that's calculus. The craziest part is because that blows my mind. And this is literally, as far as I know, the only curve that has this feature in all of mathematics. The only function whose value and slope of the tangent line are equal is the x. The only one. Everything else is different. Okay. What we start to deal with in Calc B is this. Okay. Imagine dropping a perpendicular straight down and using that as kind of a brick wall to measure the area trapped under the curve and like stops with the x-axis. So underneath the curve, stop with the x-axis and pick this space. The area under the curve is also easy. Crazy. Okay. I will see you live tomorrow where we will actually solve some exponential and log equations. But you've got the domain part down. Check that off as part of your review. Now you know it. Just c to infinity. There you go. But e to the x, my goodness, this changed everything. This, when you do exponential stuff in calculus, you always use e to the x or ln of x. I'm never going to use 2 to the x. I'm never going to use log base 4 to the x. Always going to use e to the x. And those of you moving on to calc, you will thank me later. I promise. Thanks, everybody. I will catch you tomorrow for sure, whether in class or live. No homework. Nothing you have to do tonight. I will just see you tomorrow. Thanks, guys. Questions at home? Sweet. Thanks, guys. See you tomorrow.